At this part, we will introduce wireless devices. And first is about wireless APs. From the pictures here, you can see that APs can be divided into multiple types. For example, common AP, indoor or outdoor AP, right? And for the indoor AP, different from the cables they use, we can also divide it into some detailed types, right? And we have wall-mounted AP. This is about the different types of productions. And next, let's see FAT AP and FIT AP. Based on the working mode of them, FAT AP and FIT AP are very common these days. Let's see the difference between them. Firstly, let's see FAT AP. It not only supports wireless connection, but have WAN and LAN ports. WAN ports is used to connect to the internet, right? And LAN ports are used to connect to maybe the terminals, the clients. It also supports, for example, DHCP server, clone of DNS, right? MAC addresses, VPN connection, firewalls, and so on. Multiple functions are integrated on FAT APs. So this is the reason why we call it FAT, because it contains multiple functions. FAT APs can work independently and support functions like, actually from this picture, for example, encryption, communication, and so on. The wireless routers we're using at home nowadays are a typical kind of FAT AP. Okay, and next is FIT AP. FIT AP, from the name we can know that it has removed some of the functions. And after removing these functions, FIT AP is only support, for example, wireless connection function. Right? It sets out signals. It converts, for example, wireless signals and, for example, wired signals, and transmit the data between them. As part of the WLAN, FIT AP works with management function of the AC to form a complete system. So if we use FIT AP mode, we must have an AC to manage all the FIT APs. Okay, and compared with FAT AP, actually FIT AP is more suitable for large WLAN networks. For example, for an enterprise network, or for maybe shopping mall network, just like this. Okay, after knowing the difference between FAT and FIT APs, then let's see, for the FAT AP, it integrates the WLAN physical layer, user data encryption, authentication, roaming, and network management functions. So we can only use one FAT AP to establish a wireless network. And here it shows us two typical FAT AP based networking. First is a home or SOHO networking. No matter it's home or SOHO networking, actually is similar, because the coverage of the WLAN network is not that large, right? And in this picture, we can find that we only have one AP, and it set out, no matter it set out signals by wireless or it's using cables to connect with home PCs, it can satisfy the requirements of the terminals in a home or in a, for example, in a SOHO, right? Okay, and for enterprise networking, actually we can also use FAT APs. But compared with the home networking, the size of the enterprise networking is larger, right? So we need multiple APs, and each AP set up the signals and offering network accessing for the terminals for the users. But actually, for the enterprise networking, if we use FAT APs, it has some shortages. For example, with the increasing of the number of APs, it's difficult for us to manage them, right? And we need to configure them one by one, so the working hold of the engineer is increasing. Okay, so this is about the FAT AP based networking. And next is typical FIT-AP based networking modes. The FIT-AP based networking modes are shown here. First is a direct connection. From the picture, it's quite easy to understand why we call it direct, because the APs are directly connected with AC, so it's called direct connection. And next is a layer 2 interconnection. From the picture, we can know that the network between AP or AC, or we can see that AP and AC works in the same layer 2 network, so it's called layer 2 interconnection. And obviously, layer 3 interconnection means that AC and AP works in a layer 3 network. So there could be some routing entries to enable the communication between AP and ACs. Okay, and let's see a typical application scenario. Okay, this you can see this is enterprise network, right? In this network, we can find some switches, right? For example, core switch, aggregation switch, and maybe access switches. And except that we have specific DHCP servers, we have wireless NMS platform, which are used to manage the wireless network. Right? We have ACs, we have APs, we have firewalls. So firstly, it's obvious that this network is more complex and the size is larger. Okay, so in this kind of network, FIT, AP, and AC are more suitable. After knowing the network architecture of the FIT-AP based networking, and next let's see, with the network development, let's see some requirements and how does FAT-AP or FIT-AP satisfy these kind of requirements. Okay, with the developing of the network, let's see some challenges here. Managing, monitoring, and controlling a large number of APs is a huge challenge to the wireless network. So if we use FAT APs, we need to manage them independently. For example, we should have an NMS system to manage all these APs independently, right? But if we use FIT AP and AC, actually it's more convenient for us to manage them, right? Next challenge is configuring and upgrading a large number of APs. And next, WLAN ear interfaces are prone to interference. So it's very important for us to solve the problems, for example, with this interference. For example, channel switching, for example, maybe power adjustment, and so on. Okay, and the last requirement is about the security. Of course, now network security is more and more important to no matter to the users or to the providers. Okay, so as a network engineer, we should think about that, how to improve the security level of a wireless network. Okay, and all the challenges we are facing here can be solved or are mostly solved by the FIT-AP based architecture. Let's see how does it solve these kind of problems. Firstly, monitoring and managing configurations in a unified way can help us manage the devices easily, right, and support the business control. We can find out for example, the business in the network and control them based on different types of businesses. And unified management of APs in different networking removes the obstacles caused by the absence of routing between FAT APs and the BAS. Right? Network design can be more flexible, and the FIT-AP based networking reduces the possibility of network faults and improves the fault fixing efficiency. Because it's more convenient for us to find out the faults in the network, and we have some intelligent tools to fix them. Okay, and next let's see the comparison between FAT AP and FIT AP. Firstly, about the security. The conventional encryption and the authentication methods with average security performance is supported by FAT AP, but if we use FIT AP, the RF environment monitoring is added using user position security policies, enhancing the security. And about the network management, it's obvious that FTAP and AC can manage the whole network more easily, right? Because we can manage the configuration files, and we can prepare the configuration files in advance, and then AC will deliver the configuration files to all the APs. We don't need to maybe configure them one by one. And the next is about the user management. For the FAT-AP, user permissions are managed according to the weird port to which the AP is connected, which is similar to user management in the weird networks. While for the FAT-AP, user permissions are managed according to the username using virtual private groups dedicated to wireless networks. And for the WLAN score, if we use FAT-AP, layer 2 roaming is applicable to small score networks thanks to its cost effectiveness. Right? But for the L2 and L3 roaming, is applicable to large score networks because it's non-technology related and costly on FAT-AP. So this is the reason why we say that if the network score is large, FAT-AP is more suitable. Right? And the last is value-added services. FAT-AP only offers simple data access services, but FAT-AP supports strong service extensibility. We can offer multiple services by using FAT-AP and AC. Okay, after seeing this part, next we are going to introduce AC. We just mentioned it before, right? AC is a kind of equipment that are used to manage the APs in the wireless network, and sometimes AC serves as a gateway because we have in-pass mode, off-pass mode. And if no matter we use in-pass or off-pass mode, there are different types of data forwarding mode. We have centralized forwarding, we have direct forwarding, and in the following course, we are going to introduce it. So this is also the reason why we say that sometimes AC serves as a gateway between WLANs and the external networks. If it serves as a gateway, it will aggregate the data from multiple APs, right, and connect them into the internet. AC supports user security control to support for example, the business control for each user and the service control, charging, information collection, and network monitoring, and so on. It supports multiple functions. And in large-scale campus networks, AC are the core of the WLAN and manage all the FAT-APs in the WLAN in a unified manner. The FAT-AP management includes the following functions, for example, automatic FAT-AP discovery, FAT-AP status checking, unified configuration of FAT-APs, FAT-AP configuration modification, and FAT-AP access security control. Okay, and the picture you can see here is a typical architecture of FAT-AP and AC networking. And after seeing all these contents, let's see a practice question. And let's do a summary together. Let's see, the question is that when WLAN coverage is large, FAT-AP networking is more suitable. So here you need to determine is true or false. Actually, we have mentioned it right in the content. We said that if the network score is large, FAT-AP and AC networking is more suitable or is suggested. So actually this is false, right? Okay, so that's all for this part.